Hello friends, welcome in a lecture of Mechanics of Solids subject. Myself Mitesh Patel. I am a assistant professor in a mechanical department at a Dr. Subhas Technical Campus, Junagadh. Today's our lecture topic is a center of gravity. In this lecture we discuss about what is the center of gravity and how to find the center of gravity of simple planes, simple solids and composites, planes and composites solid. So let's start the lecture. First we see what is the center of gravity. While studying some problems in engineering, we need to idealize body as a practical. This practical is nothing but we idealize the body as a particle, and this particle is nothing but a CG of entire body. CG means center of gravity of entire body. The entire weight of the body acts through this point. This is called the center of gravity. Okay. So we sometimes idealize that all the body weights are at some center point, consider as a center point. This center point is known as a center of gravity. Okay. So CG is nothing but, in short, we can say that it's an idealized point from which we consider all the weight of bodies. Okay. Complex structure like aeroplanes, ship, pyramids, etc. need to be analyzed for their stability and distribution of their mass should be such that the center of gravity remains at the desired point. So center of gravity, what is the importance of center of gravity? So it's mentioned that in some complex structure like mentioned that ship, aeroplanes and pyramids, we need to analyze that the center of gravity of these bodies is properly set at the specific or desired point, otherwise it's not properly stable in running condition or not stable. Okay. So now see the centroid and center of gravity. What is the centroid? It is defined as a point about which the entire line, area, volume is to be assumed. So centroid is nothing but it's a center of properly area, volume or line is called the centroid. And center of gravity, it is defined as a point about which the entire weight of the body is assumed to be concentrated. So it is the point from which the all weight should be considered, and centroid is the center point of the line, area and volume. Okay. Clear? It is related to distribution of length, area and volume. The centroid is effect or distribution related to distribution of length, area and volume, and center of gravity is related to distribution of mass. Centroid word is used to present a center of line, arc, rectangle, square, triangle and circle. Means the centroid which define or represent the center of line, arc, rectangle, square, triangle, means any plane and length element, center should be represented with the help of centroid. Okay. And CG word is used to represent the center of solids like a cube, cone, cuboid and sphere. Okay. So center of gravity એટલે કે સેન્ટર ઓફ ગ્રેવિટી છે એ વેઇટનું ડિસ્ટ્રીબ્યુશન નક્કી સાથે સંકળાયેલી છે, અને સેન્ટ્રોઇડ છે એ એરિયા, વોલ્યુમ અને લેન્થના ડિસ્ટ્રીબ્યુશન સાથે સંકળાયેલું છે. સેન્ટ્રોઇડ છે એ સેન્ટર પોઈન્ટ છે કેનો, તો કે કોઈ પણ એક લાઇન હોય એનો સેન્ટર પોઈન્ટ, કોઈ પણ એક એરિયા હોય એનો સેન્ટર પોઈન્ટ, વોલ્યુમ હોય એનો સેન્ટર પોઈન્ટ ઇઝ અ સેન્ટ્રોઇડ. અને સેન્ટર ઓફ ગ્રેવિટી છે એ વેઇટ સાથે સંકળાયેલું પોઈન્ટ છે કે ભાઈ એન્ટાયર વેઇટ શુડ બી કન્સિડર ફ્રોમ ધેટ પોઈન્ટ. ઓકે, એ સેન્ટર ઓફ ગ્રેવિટી છે. ઓકે, ક્લિયર? Now see the center of gravity. How to calculate the center of gravity? Center of gravity is found out by principle of moment applied to the parallel force which can be stated as, okay, so which is mentioned in figure. The moment of resultant gravitational force W about any axis is equal to the sum of the moment of individual weight about the same axis. એટલે કે સેન્ટર ઓફ ગ્રેવિટી છે આપણે મોમેન્ટના પ્રિન્સિપલ ઉપરથી ફાઇન્ડ આઉટ કરી શકીએ. અને મોમેન્ટનો પ્રિન્સિપલ શું છે? તો કે ભાઈ જે રિઝલ્ટન્ટ છે એની મોમેન્ટ કોના બરાબર હોવી જોઈએ? તો કે સમેશન ઓફ મોમેન્ટ ઓફ ઓલ ફોર્સીસ. બરાબર છે? તો અહીંયા એક્ઝામ્પલ લીધેલું છે કે ભાઈ જે વેઇટ છે એ વેઇટની એટલે કે રિઝલ્ટન્ટ એટલે કે ટોટલ ગ્રેવિટેશનલ ફોર્સ W એની કોઈપણ એક એક્સિસ સાથેની મોમેન્ટ ઇઝ ઇક્વલ ટુ ધ સમ ઓફ ધ મોમેન્ટ ઓફ ઇન્ડિવિડ્યુઅલ વેઇટ્સ. બરાબર છે? અબાઉટ ધ સેમ એક્સિસ. નાઉ કન્સિડર ધ 3-dimensional body of total weight W. Okay. Consider small element of equal size and shape whose weight are dW1, dW2, dW3 and dWn. Means the n number of small elements which having a same equal size and equal weight and shape. Size, shape and weight. All of having a equal. So n number of weight elements. So body is divided into the n number of elements which are equal in size, shape and weight. Okay. Now weight is equal, so d1 dw1 equal to dw, dw2 is equal to dw, dw3 is equal to dw and dwn is equal to dw. So total weight of body is equal to sum of the individual weights. We can say that from that. Okay. From the consideration we can say that the total body weight is equal to sum of the individual small weight. Okay, it's a simple. So write in short. So W is equal to summation of 1 to and dW small weight. Okay. So W is known as a total weight or resultant gravitational force. Okay. Now sum of the moment of all the individual weights from or at y-axis. Okay. From the y-axis we can consider the moment of all the small weights. Okay. So dW1, first moment for a dW1. So what is the first moment? dW1 x1. x1 is the distance. So first small weight is a dW1. So moment of this dW1 from y-axis is a dW1 into x1. And for the second moment of second element is a dW2 into x2. x2 is the distance from y-axis to dW2 weight. Okay. Similarly, all the small weight element moment is taken. Okay. And now write in short that summation of all the small weight moments. Okay. Summation of 1 to nth moment of all small element. Okay. Now if we require all the moments, so we can integrate all the moments. So this is the integration of x into dw. Okay. Now another thing, moment of resultant weight means the total weight of body the moment of total weight of body. Okay. And this is defined by G. Okay. From where we consider as a total weight of body, and this is the center of gravity. So the total weight of body W, so moment of this total weight W into x bar is the distance of total weight, so is equal to this sum of the moment of all individual weights about y axis. So this is the principle of moment. So according to principle of moment, equation 1 is equal to equation 2. So write it here. And now if we want to find out the x bar, then x bar is equal to integration of x dw upon w. Okay. Now we know that w is equal to summation of dw. So we can say that integration of dw. So we can write the integration of dw instead of capital W. Okay. So this is the equation of x bar and y bar, from where this is the given the specific distance of center point or center of gravity of given body from the reference axis. X bar is the x distance or horizontal distance of center of gravity of given body to the reference axis, means the center of gravity na point થી x distance છે એ x bar મેન્શન કરશે અને y bar છે એ vertical distance મેન્શન કરશે રેફરન્સ એક્સિસ થી. બરોબર છે? સેન્ટર ઓફ ગ્રેવિટી. ક્લિયર? So by this equation we can find out the center of gravity. Clear? Now center of mass. If instead of weight of object the mass of the object is considered, the procedure for finding the center of mass remains the same. According to center of weight, means center of gravity, means gravity is given the weight to the all bodies in the earth. So we can say that center of gravity is the center of weight. So similarly center of mass is find out similar to center of weight. Same procedure is follow that. So directly we can consider that W is equal to mg, we know that. So if total weight equal to m into g, total mass of body into gravitational acceleration. Okay. If you consider the small element, so weight of small element is a dw, so dm into g is a dm is a mass of small element and g is the gravitational acceleration. Okay. Now we know the equation of to find out the center of gravity of so x bar is equal to integration of x dw upon integration dw. So here the weight is there, but we have to find out the mass. So put the value of dw at mentioned in equation 2. So put the value in this equation, and gg is cancelled, gravitational acceleration is cancelled. So remaining is integration x into dm upon integration dm. This is the equation of center of mass. Similarly, we can find out the equation of center of mass for y bar. Okay. So this is the equation for find out the center of mass of the given body. Okay. From the specific or reference axis. Clear? Now center of area. In engineering mechanics, we study plane bodies represented in two-dimensional, and we deal with the area of objects. The point where whole area is to be assumed or concentrated is known as a centroid of the object. Okay. So how to find out the centroid or center of area? Okay, centroid of 2D geometry, or we can say the center of area. So similarly, we can find the centroid of area is x bar is equal to integration x into dA integration dA. Okay, clear? Now center of volume, centroid of 3D geometry. Okay, so here what is the we know that the density equation, density is equal to mass upon volume. So mass is equal to density into volume. Okay, so this is for total weight, and for small element dm is equal to rho into dv. So here this is the equation for a center of mass. So put the value of dm in this equation, rho into dv instead of dm. So rho is a cancel, and the remaining equation is a x bar is equal to integration x into dv under root dv. Okay, and similarly we find the equation for a y bar. Okay, so this way we can find out the centroid of 2D and 3D object and center of gravity of given body. Okay, clear that? Now axis of reference. Axis of reference is an axis from which we consider to find out the CG. The CG or centroid of the body is always calculated with reference to some assumed axis. This assumed axis is called the axis of reference. Okay. So center of gravity or centroid of any body is find out with assuming the any reference axis. So this assumed reference axis is the called the reference axis. Okay, clear? Now axis of symmetry, the axis which divide the figure into two identical parts, it's called the axis of symmetry. If the figure is symmetrical about y axis, then x bar is directly available and y bar need to be calculated. If figure is symmetrical about x and y bar is directly available and bar x need to be calculated. For that we have two examples there. T is the symmetrical about y axis, so we have a directly available the x bar, but we have to calculate the y bar. Okay, and here the geometry is symmetric about the x axis, so we directly get the y bar, but we have to find out the x bar. Okay, and here similar that this I section is symmetrical about the x axis, and directly we get the y bar, but we have to find out the x bar. એટલે કે જે સરખા હોય, જે એક્સિસથી બંને પાર્ટ સરખા થતા હોય એને સિમેટ્રિકલ એક્સિસ અને સિમેટ્રી એક્સિસ કહેવાશે. હવે અહીંયા ટીની સિમેટ્રી એક્સિસ શું છે? તો કે આ વર્ટિકલ એક્સિસથી બે પાર્ટ સરખા ડિવાઈડ થાય છે, બરાબર, સરખા બને છે, તો આને શું કહેવાશે? સિમેટ્રી એક્સિસ વાય છે, બરાબર. તો હવે અહીંયા ડાયરેક્ટલી એક્સ બાર આપણને મળી જશે સીધું હાફ કરીને, બરાબર છે, ટોટલમાંથી લેન્થમાંથી, બટ આપણે વાય બાર છે એ ફાઇન્ડ આઉટ કરવું પડશે. સેમ વે અહીંયા એક્સ એક્સિસથી બે સરખા ભાગ થાય છે સી સેક્શનના, તો આ છે એ સિમેટ્રી એક્સિસ થશે. તો સિમેટ્રી એક્સિસથી આપણે ડાયરેક્ટલી વાય બાર મળી શકે, તો કે આ લેન્થને હાફ કન્સિડર કરીને, બટ આપણે એક્સ બાર છે એ ફાઇન્ડ આઉટ કરવો પડશે. સિમિલરલી સેમ વે ફોર આઈ સેક્શન. ઓકે, here all things related to similar the regular section to find out the center of gravity of regular section, center of area of regular plane and solids. But if elements are composite, then how we can find out the centroid or center of gravity of composites. So first consider for the composites line element or linear element, means the wire type elements, in which elements only consider the length, not any not any dimensions are considered, because its weight is very low, so it's negligible. So only length is considered of the wire element. Okay. So entire element is given, entire composite linear element is given here. The three line is there. One is the line, inclined line, second is the horizontal line, and third is the arc line. Okay. So part 1 line AB, part 2 line BC, and part 3 arc CD. These three parts, this figure is made from these three parts. Okay. So length is a L1, L2 and L3. Okay. Length of part 1, part 2 and part 3. Okay. Distance of centroid of part 1, 2, 3 is a x1, x2 and x3. y1, y2 and y3 is the distance of centroid of part 1, 2, 3 from horizontal reference axis. Okay. એટલે કે x1 છે એ શું થશે તો કે distance of centroid of part 1, 2, 3 from vertical reference axis, એટલે કે horizontal distance થશે ક્યાંથી તો કે સેન્ટ્રોઇડ થી, એટલે કે સેન્ટર પોઈન્ટ થી y એક્સિસ સુધીનું ડિસ્ટન્સ છે એ શું કહેવાશે x. હવે x1 એટલે કે ફર્સ્ટ એલિમેન્ટનું સેન્ટરનું ડિસ્ટન્સ y એક્સિસ થી. ઓકે. x2 મીન્સ કે જે સેકન્ડ એલિમેન્ટ છે એના સેન્ટરનું y એક્સિસ થી ડિસ્ટન્સ. બરોબર છે? ક્લિયર? એટલે કે હોરિઝોન્ટલ ડિસ્ટન્સ. હવે y એટલે વર્ટિકલ ડિસ્ટન્સ ક્યાંથી તો કે x એક્સિસ થી એના સેન્ટર પોઈન્ટનું વર્ટિકલ ડિસ્ટન્સ, એને y1 કહેવાશે. y2 મીન્સ કે જે બીસી એલિમેન્ટ છે એના સેન્ટરનું x એક્સિસથી વર્ટિકલ ડિસ્ટન્સ. બરોબર? એ શું થશે y1, y2 and y3. Okay. Now how to find out the centroid or center of gravity for a composite linear element? By this equation, x bar is equal to L1 x1 plus L2 x2 plus L3 x3 upon L1 L2 and L3. Similar way for y bar, L1 y1 plus L2 y2 plus L3 y3 upon L1 L2 L3. Okay. Now for a composite lamina or composite planes, so here three composite areas is given or plane is given. First is a rectangle, second is a triangle, and third part is a semicircle. Okay. Three plane is there. So how to find out the center of gravity of them? Okay. So here center of area for is find out, or centroid is find out for a 2D element, or it's a 2D elements, means the plane is 2D element. So we have to find out the centroid. So first moment of first lamina from vertical reference axis. Okay. First lamina, moment of first lamina a1 into x1, a2 into x2, a2 upon a2 into x3. Okay. So moment of entire lamina from vertical reference axis is a1 x1, a2 x2, a3 x3 summation. Okay. Using a principle of moment, we write that, or we get this equation: x bar is equal to a1 x1 plus a2 x2 plus a3 x3 upon a1 a2 a3. Okay. Clear? For a composite volume, how do we find out the center of gravity? So x bar and y bar is find out with this equation: v1 x1 plus v2 x2 plus v3 x3 upon v1 v2 v3. Okay. Similarly we find out the y bar. Okay. Now composite solid body, for that
The equation is x bar is equal to W1x1 plus W2x2 plus W2x3 upon W1, W2 and W3 summation. Okay, all weight summation W1 plus W2 plus W3. Okay, clear that? This way, through this process we can find out the center of gravity of composite elements like a linear, lamina and solid, and volume of cone or solids, cone, cylinder and cube. Okay, so clear that? Now this is the some formulas of geometrical shape which are repeatedly used in our syllabus or study. So this is the simple line. So its length is L and center of length L by 2. Okay. Now this is the ring, wire ring. So wire ring. So its length is find out with the help of periphery 2 pi r. Okay. And center of circle is x bar is equal to r and y bar is equal to r. Okay. Here is the semicircular wire. So length of semicircular wire is a 2 pi r by 2. So it's a pi r. And the horizontal distance of from the center is a r, and for vertical is a 2r upon pi. Okay, clear that? From CG, the distance of wire is r and 2r upon pi. Okay. Now this for a quarter circle wire, pi r by 2 is the length of wire, and bar x and y bar distance from the CG to reference axis is a 2r upon pi, 2r upon pi. Here you see that the distance of CG from the reference axis is a 2r pi, 2r pi. Okay. So this distance x bar and y bar for quarter, circle and semicircle, for wire, for a lamina and for spheres, square, cube. Okay, all regular geometry, or for all regular geometry we have to remember the equations of center of gravity. Okay, or means x bar y bar. Clear? So this is given in all the equations to find out the area and the distance of CG from the reference axis x, that means x bar and y bar. Okay, so for a two-dimensional geometry, it's our lamina geometry is a for square area we find out b into d. Okay, b by 2 and d by 2, x bar and y bar. And for triangle, so area is, we know that 1 by 2 b into h, base into height, and distance of CG, okay, from x and y axis, that's x bar and y bar. So 1/3 b and 1/3 h. Okay, 1/3 b and 1/3 h for a right angle triangle. Okay, so this equations or distance value you have to memorize for all the two-dimensional figures. Similar way, for a semicircle, quarter circle, semicircle, area is a pi r square by 2, and the distance of CG to axis for x bar value is a r, and y bar value is a 2r upon 3 pi. Means distance of CG to reference axis means y axis and x axis. Okay, clear? Now for solid, some regular solids are there, cylinder, cone. Okay, So for cylinder, what is the volume? Volume equation for a cylinder, pi r square h, okay, and x bar is a r, and y bar is vertical distance of CG from x axis is a h by 2. Horizontal distance from CG to y axis is a x, okay, sorry, is a r, okay. Similarly, for a cone, from CG to vertical distance on a vertical axis, distance is a r for a cone, okay, and the volume equation for cone is a 1/3 pi r square h, okay, and the y bar value is a means distance of CG to horizontal axis is a h by 4. So all these equations for sphere, cylinder and cone you have to memorize, and x bar, y bar value, okay, clear that? So thank you for listening a video, and if you have any query then feel free to ask to me. Thank you again.